In 10.2, we're talking about rational expressions, and you want to remember that rational means fractional, and rational exponents. So if we have 9 to the 1/2. Now I've got this pretty little flower over here that I drew, and it's here to remind you of some things that are going on with this situation. So we want to keep in mind that here at the bottom, under the ground, are the roots. And so that's what I want you to remember, is that this is the number that's under, and so this is going to be our root number. And that's the number that comes outside of the radical. So you have lots of words that you have to pay attention to here. Rational, exponents, radical. So what we're going to do when we have this situation is we're going to rewrite this fractional exponent into something that makes a little more sense. So if this is my root and it's the radical, then that means the 2 is here. And again, I'm going to put the 2 to emphasize this is where it goes, but you won't see it anywhere else. When we have a radical sign, that means it is the square root. But for this, I want to emphasize that. So I've got the square of 9. And we already know that the square root of 9 will equal 3. So if we have 27 to the 1/3, we will rewrite that as the cube root of 27. And then we want to remember that 27 is 3 times 3 times 3, and when I go to simplify that, my answer is going to be 3. Another little reminder about things that we've talked about in the past is the exponent affects what it touches. Okay? So as a reminder, let's look at, if I have -3 squared, or -3 in parentheses squared, this 2 is only touching the 3. This 2 is touching the parentheses. So that means everything in here will be squared. So this one would be 3 times 3 is 9. And then we have to take that negative sign and bring it down. So our answer would be -9. Here, since the square touches the parentheses, everything inside gets multiplied, and so we end up with a positive 9. So we want to keep that in mind for some of the work that we're going to be doing. So we have 9m, and the half is touching the parentheses, so everything will go under the square root. Now I can only simplify this 9, so it comes out as 3, but then I'm left with that m inside. This looks very similar, but remember, it's only touching, the half is only touching the m. So the 9 stays outside and the m goes under the radical. So you've got to be careful with these exponents when you have more than one number or letter in here in this term. You've got to keep in mind it affects what it touches. So I want you to try a few of these before we move on. So let's see. Let's do. Let's just try those two. So go ahead and pause your computer and pause the video and go ahead and try those on your own, and then come back and look at them. I'm going to continue and work. All right, so remember the negative is, the half is touching the 49. It's the negative, we think it goes with it, but it doesn't really. In this situation, the half is only touching the 49, so that's the only thing that comes under the radical sign. And then we square it, but the negative stays with our answer, which is a good thing. If we had included the negative, then remember, you can't take the square root of a negative. This would have ended up being not a real number. Here, because the half is touching the parentheses, everything here goes under our radical, and then we take the square root of both of those. All right, so you want to remember my little picture of the flower. Now we're going to look where we have a rational fractional exponent where it has your root, but it also has a number here other than 1. So the 5 here is going to be the 5 is your power, and the 4 is your root. So you have two ways to write this. You can write it as the 4th root of 16 to the 5th power, or the 4th root of 16 and then take all of that to the 5th power. Now, I don't know about you guys, but I don't know what 16 to the 5th power is. When I plug that into my calculator, I'm going to get a super large number, and then I have to back out of it to get the 4th root. So this isn't the best way to work it. This is going to be the best way. Take and put the power on the outside of everything, because I can easily do the 4th root of 16, and then I can take that number to the power of 5 much more easily than I can do the 16 to the 5th power and then back out of it. So here we have, the 4th root of 16 would be 2, and then to the 5th power, and that is going to give me, remember we're doing this 5 times, and so my answer here would be 32. So remember our little picture, the number on the bottom, the roots of the flower, that will go in your root position next to your radical sign. The number on top is a power number, and we want to take and put it on the outside take the root first and then do the power. So here it's included, the negative is included in the parentheses, so we will rewrite this as the cube root of a negative 125, and then all of that will be to the power of 2. So the cube root of a negative 125 would be a negative 5, and then we're going to square that to give us a positive 25 for our answer. Okay, here we have this negative exponent. And so what we need to remember is from our exponent rules, the negative exponent rule, you're going to change locations. And what I mean by that is we're looking at the numerator and the denominator. So we're talking about numerator and denominator. And then we want to make the exponent positive. Okay, so that's our negative exponent rule. Change location, so if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes up to the numerator. And you make the exponent positive. So here, if you have a whole number, it's in the numerator, because I could take and write this over 1. And then you can see that is definitely in the numerator. So I'm going to have to change locations. So that means it's going to come to the bottom and do my 2/3 becomes positive, and I need a number up here, 1. So if there's not another number that's in the denominator, you need to put this. Then we want to rewrite it using your radicals, your root, and then your power. Well, sorry about that. Wanted to extend that line. So when I take the cube root of 216, I'm going to get 6, and we'll square that. So in 10.1, I recommended that you go to the internet and find a list of cubes and squares. And I think that would be helpful for this lesson also, so I don't have to sit and think for too long. Or use your calculator, do the cube root on your calculator so that you're not sitting there too long trying to figure out what the heck goes into 216. So this number, which I think is really strange looking with this negative fraction as an exponent, simplifies to this 1/36 fraction. Let's do another one with this negative exponent, and we are going to look at a lot of our exponent rules, review them in this lesson. So we've got 1/m to a negative 6/7. The negative exponent tells me to change locations. This is in the denominator, so I'm going to put it in the numerator and make the exponent positive. Now I put this line here to emphasize this is going from the denominator to the numerator but I don't have anything in. I mean, if we took and flipped this down, I'd have a 1. And so I can go ahead and simplify that also, where this is going to be just m6 to the 7. Now, if I want to, you're going to have to be really careful. So, you know, I want to make a note here on my math lab. Follow directions. They may ask for you to leave your answer in a rational form, which this is the rational, or radical. So this would be rational, the m to the 6th, 7. This would be radical, where you would take, and we would do the 7th root of m. And in this case, since we can't simplify it, we could put the 6 here. Or we could do it like when we have to do the work, 7m, and then enclose it all in parentheses with a 6. But I want you to be sure that you're paying attention to this. That's going to make a big difference in your answers. Not all of them are you going to simplify it into the radical form. They may ask you to leave it in a rational form. So with this problem, we are multiplying, and so that's the product rule. For exponents. And the product rule for exponents tells us to add the exponents. Well, we're adding fractions. So what do you need here is a common denominator, which we already have. So when I add those, I get c to the 9/5. This is my answer in rational form. Now we have division. This line is your division line, and that is quotient rule for exponents, which tells me to subtract the exponents. So that means I'm going to have 1/11 minus 1/22. I'm subtracting, so I need a common denominator. 11 will go into 22, so we will use 22 for both of these. But I have to change this fraction, so times 2 times 2 times 2 to give me 2. Now I can do the subtraction. Now all I've done is take care of that quotient rule with the exponents. This is going to be my exponent for the y. So when I go to write my answer, it's y to the 1/22. Here I have an exponent inside and an exponent on the outside. I've got 2 of these for each of what's inside. And so what's going on here is this is the power rule. And with the power rule for exponents, we are going to multiply the exponents. If you don't have a good grasp on the rules, you can review this in Chapter 5. You can always go to the multimedia library on my math lab and look at the ebook. Go back to Chapter 5 and look at a review of all of the exponent rules. All right, so what this is saying is I've got 16 to the 5 halves and m squared times the 5 halves. So let's deal with one of these at a time. So if I take the square root of 16, and I'm putting the 2 for emphasis, and then we do it to the power of 5, and then the m, when you multiply, this is 2 times 5 is 10 over 2, and you could take the shortcut and cross cancel, but I'm going to show all the steps with this one. So then the square root of 16 is 4, and to the 5th power, m, 10 divided by 2 is 5. But we want to go ahead and simplify this out, and so you're going to do 4 times 4 times 4 times 4 times 4. So drag out your calculator. This is not going to be a small number. Okay, so you'll probably need lots of practice on this section because you have lots of stuff going on. You've got the rational exponents, which we have not seen before. You've got all your exponent rules that we've looked at a little bit at the beginning in the review, and if you took the 307 class, then you saw them in Chapter 5. So if you don't know those well, then you really want to review those. You really need to know these. You need to be able to recognize the difference, especially between the power and the product. So just keep that in mind. All right, we're not quite done with this section. Let's go on. You will also see these rules again in another section, so you do want to be sure that you're understanding them. Okay, so let's switch gears a little bit. They want us to write a radical expression. Well, we already have it in a radical expression, but to simplify it, we need to change. So to simplify, change to rational exponents, simplify, and change back to radical form. So in this situation, I'm going to have x, my fraction or my rational exponent, Remember, the 10 is the root. And then when I simplify that, and then I change it back to a radical, I end up with the square root of x. So again, pay attention to those directions. Very careful. Be very careful with those. So the first thing we need to do is we need to rewrite this with rational exponents. So we'd have y to the 1/5 times y to the 2/3. Always remembering that this is the root, that's the bottom, that's what goes underneath. Then we're multiplying here, and that's the product rule. Which, I know it doesn't even seem to make sense. Product rules means we're multiplying, but we don't multiply the exponents, we add them. So it gets to be confusing. So that's why it's very important that you're understanding the rules. Well, I'm going to add, if I add 1/5 plus 2/3, I need a common denominator. The fastest way to get that is to multiply the 2 that you have. So it was 5 times 3, so 1 times 3. 3 times 5, so 2 times 5. And then now I can add those together. And remember, this is my exponent. So I'm going to go over here, and it's y to the 13/15. But my directions called for a radical expression. So I need to change this. Y is here, the root is here, and in this situation we can go ahead, since we're not having to do anything with it, we can go ahead and put the 13, the power number, we can go ahead and put it inside. This works very well. Okay, that's about it for this section. It is also probably going to take you a little bit of time, and make some notes for your that you can use on your test, and especially for your final exam. I would go ahead and start writing some notes. What I let you use for the final is 1-page front only of notes. And I recommend that you do these. This is one of those things when you get in a testing, stressful situation, this is one of those things where you're going to make mistakes because you're going to get these backwards. You're going to look at this and go, oh, we're multiplying. So that means 1 times 2 and 5 times 3. And 2 over 15 is not what we came up with for our answer. So this is why it's going to be important. I would go ahead and you should just go ahead and start doing that now. Go ahead and start getting ready for your final. And write some notes. 1 page front only, and then when final time comes, then you'll have your notes ready to go. All right, hope you guys have a great day, and I hope this goes well for you. Email me if you have questions.